Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, how are you all? I welcome you in Pakistan International School Thai Spiritual Learning Classes, and this is class of subject science for grade 6. Dear students, today we will start our new chapter, that is chapter number 10, about properties of light. In previous lectures, we have finished our chapter number 8 and 9, in which we have talked about energy and its forms and forces and machines. Now we will talk about properties of light. And we will talk some properties of light in this chapter and some in grade 7, inshallah. And then we will talk about laws of reflection. So let's get started. This is your chapter number 10, properties of light, of your book. What are the properties of light? Three basic properties of light are there, like light can transmit, can absorb, and can reflect. These are the main properties of light. And one is more, that light travels in a straight line. You have seen that before in the previous classes. So when we complete this chapter, inshallah, we can differentiate transmission, absorption, and reflection of light. We'll see laws of reflection, differences between smooth, shiny, and rough surfaces as well. What are regular and diffuse reflection? We'll see this one also in this chapter. We'll see some everyday applications with regular reflection and diffused reflections. Also, we'll see some ray diagrams of light reflected from plane mirror, as well as now we will see how image formation is done by plane mirror, like by which you in which you can you see your face, that plane mirror. And then we will compare characteristics of image formed by plane mirror and pinhole camera. Then we'll see about some reflecting surfaces like microscope and reflecting telescope. We'll see some instruments using these mirrors, and then we will talk about very important and interesting activity, that is about kaleidoscope. We will have the relationship of angles between two mirrors and number of images. You can see with the kaleidoscope how it is done, how its formation and working of kaleidoscope. Then we will see some mirrors and usage of them in daily life. And then we will see image formation in convex and concave mirror, because not only plane mirror, there are some other curved mirror also. Curved mirrors like the curve from outside or inside. So we will talk about them also in detail in this chapter, inshallah. So today we will see some properties of light. We know that light is a form of energy. Yes, and it is given out by luminous objects. Luminous means shining objects, like the objects which give off their own light. For example, there is sun, there is bulb, there is candle. So these all are luminous objects. Some objects which do not give off the light, those are called non-luminous objects, definitely. Like there is paper, there is wood, there is mat, we can see clothes, there is wall. These are non-luminous objects. Okay, so light is having its property to reflect, pass, or transmit or absorb by the objects. So when the light can pass through transparent material, that transparent means the thing through which we can see on the other side. For example, a glass, water, clear plastic, like the plastic sheet or covering of your book or your notes, the outer covering, that is plastic sheet, which is clear, we can see on the other side of that. Air also, those all are called transparent objects through which we can see on the other side. This is very important to learn these things because they will help you in the next slides. Light cannot pass through some objects, some materials, those are called translucent materials, through which light cannot pass and we cannot see them on the other side. For example, any tracing paper, we cannot see on the other side. We can trace a little, but we cannot see on the other side properly. It means light cannot pass through that. Frosted glass means embossed, in which there is um, designing over there and some other materials mixed, like it's not clear glass. The wax paper also, which we use for baking purposes, so that is also having not the property of transparent, that is called translucent material. So very important properties of the light, which we are going to see now, that is transmission, absorption and reflection of light. So we know that light behaves in different ways on different objects, like through some it can absorb, it can reflect, it can pass. So first of all, we'll talk about transmission. Transmission comes from the word transmit. Transmit means from one side to another side. It can move deep inside. So when light falls on transparent object, it is transmitted to the other side. That's why we can see across the transparent objects. For example, this is a glass, and light is transmitted from one side to another side of the glass. So this is clear glass. So we can see from here. For example, if this is our eye, so we can see from here up on the other side through glass. This is called transmission of light. So this is called transparent surface, and this ray is called transmitted ray. This is the ray which is coming from the, we can say, from the sun, from any luminous objects, and if it is transmitted on the other side, it is called transmitted ray. Sometimes it happens, like for example, this is any, sorry, the line is not straight, so here we can draw this straight line. This is transparent object, and the light when fall on it, it bends a little. It bends a little from here. There's not having the same direction, same angle. Okay, now we'll see absorption of light. How does light absorbs in the objects? When light falls on rough, opaque objects. Opaque means very like having some color, and that is from which the light cannot pass through that. Most part of this light is absorbed and changed into heat energy. So because light is coming towards, this is the rays of the lights, they are coming towards the surface, but the surface is sometimes opaque, like a paper and like wood. So and also sometimes it is a rough surface, it's not smooth. So what happened, the light does not transmit on the other side, as well it does not reflect, so it absorbs here. When it absorbs here, it means the light energy is going inside, so it changes into heat energy. So black surface absorbs most of the light. If the surface is black, so it absorbs most of the lights. That's why light cannot pass through opaque object or the black surfaces. So like around the pinhole camera, we use black surface, so that light cannot pass through this black surface into the pinhole camera, as well as most of the cameras are made in the form that they are having black or gray or darker color, as well as black color clothes if we wear in summer or if we wear in winter, because they absorb most of the sunlight and heat energy. That's why we skip the dark color clothes in summer, because in summer already we are having a hot environment outside. Very it's very hot out there at our homes, like due to so much scorching heat and light of the sun. So we just avoid to wear black color clothes and dark color clothes. Especially we wear light color clothes in summer, and we wear dark color clothes in winter, because the same reason, it absorbs the heat and light, so it keeps our body warm. That's why we um, avoid dark color clothes in summer, but we prefer dark color clothes in winter. Now we will see reflection of light. Another property of light, that how does the light reflect through the surfaces when the surface is smooth and shiny. For example, a metal plate, a mirror, water, because it is also shiny. So light reflects and bounce back. These are the rays of light, incoming lights, and they strike here and move back. So they are called bouncing of the light in the same direction in the from where they are coming, and then it reaches to our eyes, so we can see our image in the mm, smooth and shiny surfaces. So that is called a reflection of light. In our daily use, in our daily life, you can see lots of like you can have lots of examples of having this reflection of light, like when we see in the mirror, when we see a shiny plate, when we see in stagnant water. Stagnant means which is stopped water, not running and moving water. So we can use these type we can see these type of uh, properties of light, especially reflection, but there is other properties, the diffuse reflection also there, and we will talk about in the next slides also. Very important, very common example, that when we just park our car outside, so what happens in the car? If it is summer, so it is like um, too problematic to sit in the hot car, warm car. Um, so how it does happen? A part of light passes through the surface, this surface which is windscreen. Some part is reflected and rest light is absorbed in the surface. So you can see, we can see the images of like these trees. If you can see your own image in this windscreen, because the light is reflected from here, but sometimes it happens the light is absorbed also into the surfaces, because the light can reflect also and move into like deep inside it, absorbed here. Absorbed means transmitted also, because this is clear glass, so it can transmit inside. And like this is all the metals, so like, and the colored metal is colored, so the light can be absorbed through this, we can say opaque surface, absorbed also, absorbed inside the car. That's why by the absorption it just changes that into heat, so that's why our car gets warmer. So here we can see car windscreen light incident ray, like which is falling on the screen, and then it reflects over there, it is transmitted over there, and some rays are absorbed here, so by which it just changes into the heat energy. How reflection occurs? In this chapter, our main focus is on the reflection. So how does this reflection occur? So it occurs when a light ray, because we know that light travels in the straight line, that straight line is called a ray. So strikes on a shiny surface, this is a mirror, so it strikes back and bounces off, like when it strikes here and just move back in the same direction. So that is called bouncing off the light. So the ray that strikes the shiny surface is called incident ray. There are some terms which we have to know. Incident ray, which is falling here. Then the bouncing off, the ray that bounces off, that is called reflected ray, because here is no absorption and transmission. Here is reflection only on the plane mirror, so that is called reflected ray. At the point at which the incident ray, this ray is striking here, this is called point of incidence. So this is called point of incidence, I, point of incidence. The line perpendicular to the point of incidence is called normal, because when we see the image formation in this one, in this lecture, so these terms you must remember. The normal is the line from the point of incidence, like it is perpendicular to that surface, mirror or any surface. The incident ray forms the angle to this normal. This is the normal line, like this is the central line. So light is striking in this direction, in this angle. So this is called angle of incidence, because this light is incident light. That's why it's called angle of incidence. And when the light strikes back, so this is called angle of reflection, because light is reflected from here. So this is called angle of reflection. So just wait for Adhan, dear students. Okay, so the angle of incidence is denoted by small I, and angle of reflection is denoted by small r. So these terms have to you have to keep in mind while we study the image formation. Okay, laws of reflection. When the light falls on any surface, shiny surface, it bounces off. So there are some laws for that that are valid and understood. You have to remember on your fingertips. So they are experimentally proven. We also prove here with the experiment that the angle of incidence is equal to the angle of reflection. If you see, this is incident ray. This is incident ray. It forms the angle of incidence here, that is called that is not theta, that is actually like representing the angle of I, like angle of incidence. So you can see here angle of incidence. So when it is reflected, this is reflected ray, and this is ER, and this ER represents the angle of reflection. So angle of incidence, where incident ray is falling and incident reflected ray is going on. So this indicates that angle of incidence is equal to angle of reflection. Okay. So next point is there are 2 points of laws of reflection. Number second is the incident ray, this one, the reflected ray, this one, and the normal at the point of incidence. This is normal and this is the point of incidence, this one. All lie on the same plane. They are called the laws of reflection. All lie on the same plane. Like this is the mirror. On this side, on this plane, these 3 lines will be on the same line, on the same plane at this side. So these have to be like normal cannot be on this side. If incident ray is this side, so reflected ray is not this side. It's a plane can be changed. So here norm on the same plane, they can be at the same plane, all the three lines. Okay, to prove the laws of reflection, we will do an activity. So this is written in your book on page number 101, and that is included in your long question also. For that, I'm just gonna share a short video of that. You can you can understand how this activity has to be done. I'll explain it with that. Yes, dear students, here you can see, first of all, we have to draw one line, straight line on the paper, on the white paper, and this line represent that here we will keep the mirror. Now, on this line, we'll take a point in the center and we will just mark a straight line that acts as a normal on that. So we'll just give any number. In your book, the number can be changed O in the center because this is the normal which we have drawn, and this line, a straight line on which we will keep the mirror. Then what we do on the center, on the normal, we'll point here 90 and we'll mark on one side the angle at 60. Like it means it will have 10, 20 and 30 degree on this side. Then we join the line from the center to this angle, which with the pencil, and a little longer so that it must be clear. Then we'll place the mirror on the line MN. So that's why we have drawn the straight line. And now you can see the image of this line on the other side. We are marking this as a normal, as point A, like the line A, line B on the other side. That will take 2 pins and we'll apply vertically on this line. You can see here both of the pins on this straight line. That's why we have just placed this we have drawn this straight line at the angle of 30. We have written here 60 because the angle which becomes here, that is on the protector, that is 60, but actually it is 30 from here, from the normal. So now we will see the image of these pins in the mirror. You can see, and we take a point on which the position, at a position on which both of the pins must be in straight line, not on the left, not on the right. You can see here they are not adjusting on one another. Now we'll see here, this is the straight line. Both of the pins are in straight line. This pin and on the other pin, they have to adjust on like this for the paper, not this one. Now we'll take another pin and we'll adjust the pin just right before of that, so that all these 3 pins must be in the straight line, and the next 4th one also, so that these 2 pins must be in the straight line of the image of these 2 pins which we have adjusted before, which we have fixed before. So now you can see clear line. You can see this one on the other side. If you move on the right or left, the image will be changed. The direction of the image will be changed. Now it is in the straight line. Now I'll take out the pins at this point and we put circle and we just write the straight line. We mark the straight line over there with the scale. And then how we can like prove the laws, like we will check with the protector. Now you can see here, this is also on 60 and this is also on 60. We have drawn this one before and now we have drawn, adjusted this angle. This is a reflected angle, angle of reflection. So this is also on 30. If we just see, this is 30 also, and from that is also 30. Now we have proved that angle of incidence is equal to angle of reflection. So our laws of reflections have been proved, and all three normal in angular incident ray and reflected ray all lie on the same plane. So hence we have proved this activity by the experiment. I hope you understood it. Okay, here we can see that angle of incidence is equal to angle of reflection with the normal. Okay, now we'll see other two some surfaces of the reflection. Like there are two types of surfaces, like smooth and rough surfaces. So a plane surface, that is called smooth surface. So when parallel light rays of the lights strike over it, so they reflect on the same angle. So that is called regular reflection, like we see in the mirror. Our image or reflection see in the mirror. Rough surfaces, when the light strikes on the rough surfaces, so when light strike, you can see here it's striking from here, it bounces of this direction, it's striking here, it bounces of this direction, it's striking here, it bounces of this direction, like this. The angles are changed. Here the reflection is occurring, but you can see the light is spreading in different direction. That is called diffused reflection of light, and we can see this diffused reflection of light in our daily life in many ways. So here you can see the light is spreading a lot in different direction. This is called diffused reflection. So in our daily life, a regular reflection of the light is seen when we look into the mirror, because this is plane surface. Wow, the baby is enjoying by seeing, looking at its mirror, in the mirror, its reflection. We can turn the sunlight towards dark places by regular reflection with the help of a shiny surface. How we can do this? Like the sun is coming, and we just take a mirror, and we just keep this in the path of the light which is coming to the sun, and then we strike it on any place. So we can bend the direction of the light to any other surface in the dark as well. Sunlight does not reach directly in our rooms, so but we see the things in the room. How? This is due to the diffused reflection, because light which comes from the sun, it just strikes over these dust particles and move in different directions. So light spreads in different angles, so we can see in whole of the room. Next one is we can see things just before the sunrise and just after the sunset due to this diffused reflection, because the light is striking on the dust particles, on the water vapors which are present at the time, and then they spread all over around, and we can see from this. Okay, dear students, that's it for today. I hope you understood the lecture. We'll continue this one, inshallah, in the next lecture. Wish you all the best. Allah Hafiz.